Is the structure of the universe precisely arranged so that it can be discovered by the human mind? And if so, what does that say about whether or not a God designed it? Welcome to another edition of the Bordering on Belief podcast. Today, I'm delighted to be joined by Professor Robin Collins. He is Randy Basinger Chair of Philosophy at Messiah University in Pennsylvania. Robin, thank you very much for joining us today.
You're welcome. It's good to be here.
Let's start off by asking, what do you mean when you say the universe is discoverable?
That means we can, using our scientific instruments, we can come to understand its basic structure. So, for example, we have discovered the nature of atoms. That was part of the discoverability of the universe, something we didn't know 200 years ago. We've discovered the structure of the universe that is very, very large, and the galaxies are receding, and that it started in a very hot condensed state called the Big Bang. So, just numerous areas we've discovered the universe, including things that are useful for technology like electromagnetic radiation, which we call light at radio waves, etc. And electromagnetism is the reason we're talking here right now um, over large distances. So there's all the technological progress we have made is just a result of understanding this fundamental structure of the universe. If you just think about it, this is huge. By before 1900, we were in horse-drawn buggy, and since then, we have the internet, we have uh, this kind of thing where you can talk to each other visually. We have the artificial intelligence. There's just a huge, huge bunch of stuff has happened just in a mere 100 years compared to all of human history, and that's a result of coming to understand the fundamental structure of things. It used to be where, you could understand how a water wheel would work just by looking at it. But now we require theories. If you ever opened up a radio or something, all you see is just kind of these things that look like uh, disc, and then look like cylinders and stuff. You would have no clue on why it can do what it does. Or if you opened up a computer without the theory. So we have a theory of electromagnetism, an abstract theory that allows us to understand and hence develop the technology.
Okay, well, that leads us into the question of what role does mathematics play in making the universe discoverable?
At the fundamental level, mathematics is absolutely crucial. So we're talking about different levels of science. Like you don't need to know a huge amount of mathematics, let's say, to do biology or geology. You need to know some. So you can understand, let's say, continental drift theory. You can express it all that the continents are moving apart because of um, lava or magma moving up, movement of all that underneath the earth without a lot of abstract mathematics. But as you get to deeper levels of physics, the mathematics becomes more abstract, um, like into general relativity or quantum mechanics, and then into particle physics. And of course, and in those areas, you get a combination of two things. You get more abstract mathematics, but more elegance in some sense, what the physicists and scientists call beautiful mathematics, which is gets links into discoverability because it's been finding that beautiful mathematics and then pursuing equations that are beautiful and simple. There's an elegance has been a very fruitful way of finding out about the structure of the universe. And without that guide, the guide of beauty, and is also a motivating force, we wouldn't have made the kind of progress we've made.
Now, many people can marvel at the discoverability of the universe or the elegance of the fundamental physical laws and just stop there. And many famous scientists have done. Why do you think that discoverability requires an explanation?
Okay, so first of all, you can imagine There's different kinds of discoverability. One I had mentioned the elegance and beauty of the equations themselves and the mathematical framework that are aesthetically attractive, but also serve as a guide. So, but then I've taken that's what many scientists have already noticed, like um, you uh, you have famously Eugene Wigner, one of the major figures in founding of quantum mechanics, the core theory of fundamental physics in that we have now, a most successful theory ever in history. um, when he was particularly talking about that, he said the miracle of the fittingness of mathematics, particularly the kind used in quantum mechanics, to nature is a miracle in which we neither understand nor deserve. That's how he ends a very famous article on the unreasonable effectiveness of mathematics in the physical sciences.
But did he go further to try and explain why, or did he just get to that point and say, well, that's enough to say?
Yeah, so he didn't say why in that. I mean, it's kind of for many people pointing to something more going on, that there's a great architect or something of the universe. But you have to realize in science, it's sort of in physics for various sociological reasons, mentioning God or was kind of considered out of bounds. So physicists would say all these sorts of things, but not explicitly bring in God. Maybe sometimes in private correspondences or other areas they would. Early on, Sir James Jeans, in his book on the mysterious universe, he was also a very well known physicist, did talk about it was like the universe was a thought in the mind of God.
And just to be clear, you regard looking for an explanation for the discoverability as within the realm of physics and science. You don't regard it specifically as a metaphysical question, or do you?
I regard it as a metaphysical question. I distinguish between, naturalistic explanations, invoking natural entities, and kind of what I call um, a methodological theism, which is you can your metaphysical beliefs um, affect what you consider a plausible hypothesis. So I think in the terms of the Big Bang Theory, for instance, it was actually developed originally by a Belgian priest, the idea that the universe had a beginning, which was resisted by most scientists for, let's see, about 40 years until the evidence of the cosmic microwave background radiation became very definitive because a lot of scientists didn't, it pointed too much to a kind of creator God as you find in the Hebrew Bible.
Now, you go one step further. You're not just saying that the universe is discoverable, you're saying it's fine tuned for discoverability. Tell us about the fine tuning side to this.
So that goes a step further. A lot of people have pointed out, like I had mentioned, Eugene Wigner, Albert Einstein, and many others have pointed out how amazing it is that we can the miracle of being able to understand the universe. And Einstein said that was the most miraculous things about the universe. It was understandable at all. So many have already pointed that out. Um, and I pointed some of that out early in the 90s, and then and beyond. I made that a little more specific. But what I did by 2010, while working on another kind of fine tuning, which is very well known, the fine tuning for life, the fundamental parameters of physics are adjusted just right for life. I kind of stumbled on this other kind of fine tuning. So it's useful to explain in explaining what this is. I have a couple things to do. First of all, what is a fundamental parameter? What is the fine tuning for life? And then what is the fine tuning for scientific discovery?
Let's build it up then. Yeah, I can build it up through those stages.
Okay. So first of all, what is a fundamental parameter? Well, an almost fundamental parameter would be something like the mass of the proton or the mass of the neutron. Um, but now they're not quite fundamental because those are made of protons and neutrons are made of what? More fundamental particles called quarks, just like that atom is made of protons, neutrons, and electrons. protons and neutrons are made of something more fundamental, um, quarks. And those are the most fundamental particles we know in a theory called the Standard Model of Particle Physics. And that model contains um, really about, let's see, contains around 9 10 mass parameters. I'm just trying to don't have that right off the top of my head, but they are different fundamental particles with their own masses. Like one of them is the Higgs boson, discovered in 2012, which was a big deal at the time. Often called the God particle because it played such an important role, and they discovered what its mass was and discovered its existence. So they're like the periodic table in for chemistry, these fundamental particles in the Standard Model. Okay, and then they have masses. The masses are a fundamental parameter. There's other ones like the strength of forces, like the strength of gravity. Not in a particular planet, but just there's a number that characterizes the strength of gravity via Newton's law. There's a big number G, which determines how strong gravity is. It's if I could just say in a quick equation, it's at these a simple equation. It was Newton's law that the force between any two masses, like you and the Earth, which determines how much you weigh on a scale, is given by G times the first mass, u, times the second mass, the Earth, divided by the distance between you and the center of mass, that distance squared. So G determines that strength. So if you double G, you'd have twice the force between you and the Earth. If you made it half, you'd have 1/2 the force. So that determines for any body like the Earth, that's helps determine how much how much force it exerts on the surface. Um, and so that's a fundamental parameter. And other ones determine like the strength of the electromagnetic force I'd already talked about, like the force between electric charges and magnetic fields. And another one determines the strength of what they call the strong nuclear force that keeps electrons and the protons bound together. Protons are positively charged in a nucleus, and so they would fly apart if they weren't the strong nuclear force. So it keeps the protons together and the neutrons. And that has a number characterizing its strength. And there's a fourth force called the weak force that also plays an important role. And so those are other examples of parameters. And then there's some others that play roles in physics. So now that's what a fundamental parameter. So you can think of them as like dials that you tune. Like, your thermostat on your wall is a dial you tune that determines the temperature of the room. That would be like a fundamental parameter that you have. Um, so uh, it would be an example of that in an everyday case. So these are the dials that the universe has. And what's nice about the fundamental parameters for fine tuning, you can quantify. You can ask yourself, what happens when you change the dial? You move it one way or the other. What would happen to the physical structure of the universe? So much of this was discussed in the area of what's called the fine tuning for life, or all. Just a second here. The anthropic fine tuning um, is that what was found is that you change these dials by a very slight amount. For example, change the gravitational force constant. You can't get any kind of the kind of material complexity that could lead to life. So you might not be able to get stars, for instance, and then you don't have a source of energy for life, or you might not get matter, might not in the universe as it blows out, might not condense. So there's a lot of different effects that occur, and that there was extreme fine tuning found. I mean, in unimaginable degrees, like um, not like one part in a billion, 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 billion of fine tuning for some of these things. And so that led to the fine tuning of life. And people said, well, there has to be, you know, something's going on here. This couldn't just be by chance. And then a couple of explanations were proposed. One was some kind of design or intelligence behind the universe. The other was called the multiverse hypothesis. And this is where discoverability becomes really important because the second explanation won't work with discoverability. Um, so the second explanation was multiverse, and the idea was, well, maybe there's many, 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 many different universes, and each with their own value set for the constant. So you get enough of those. Eventually, one of them's going to turn out to be just right for life. Just like if you had a lottery and you generate enough tickets, somebody's going to win. So one of those universes is going to be just right for life. So that seems clear. Give it enough chances, that's going to happen. And we're talking about a huge number of universes here, enough to cover it. And then the next part of the claim is, and of course, any observers that evolve in such a universe, like us, are going to observe it to be fine tuned. So there's no coincidence that there is observers like us, and it's no coincidence we find ourselves in such a universe, so we couldn't have found ourselves in anywhere else. Often it's compared to like what's called a mini planets hypothesis. Like if our universe is large enough, it's no surprise that on some planet's going to be the right distance from the sun and have other features just right for life to evolve. Like our Earth is just the right distance from the sun. If it's too far away, you get an a runaway greenhouse effect, or too far away, you get a runaway ice age that never ends. And so it becomes what they call icebox Earth. Or if you go too close, like you get a runaway greenhouse effect and there's no water. So it looks initially, you look at those features, well, isn't it miraculous? Our Earth is just right for life. But the many planets person says, well, wait a minute, there's many, many, many planets in the universe. There's so many that eventually some planet is going to be just right distance from the sun and other features for life, and then the life that evolves there is going to look back and says, "Wow," if it's an observer, "Wow, we everything looks fine-tuned just for us." Um, and it does that with evolution, even if evolution is extremely improbable that there'd be a first cell and observers such as us would evolve. They'll say, given enough chances, it's eventually going to happen. And then as observers are going to look back and say, aren't we lucky? Well, of course, they're going to have to be in a lucky place because that's the only one allows for life. That's called an observer selection effect. And so that's the other leading challenge to this well-known, what's called anthropic fine-tuning. But discoverability, it won't work with that.
Okay, so before we get on to that, there's one more. Since you brought up fine tuning for life, there's one more explanation besides chance in a multiverse and design, and that is necessity. That it was necessary that the universe formed this way. What do you say to that as a place to stop on this discussion?
Okay, so if it was necessary the universe formed this way, that's still a big coincidence that the necessity was just for life. Let's suppose I give an example like this. Let's suppose that I'll give a couple of examples. One is I used to live in, I grew up in Washington State where there's the Cascade Mountains, and we occasionally go out hiking in the Cascade Mountains. So, and my brother would occasionally go before me. So I come up on this trail, and below this cliff is rocks arranged in a configuration because, welcome to the mountains, Robin Collins. And I said, oh, that's really, really strong evidence that my brother's been here. And the skeptic says, oh, no, everything that occurs in the universe is of necessity. So, of course, of necessity, those rocks would just be arranged in just the right way for them to fall off the cliff to say, welcome to the mountains, Robin Collins. Now, I would say in response to that, well, that's very unlikely that the necessity would be just such that it would do that. Very unlikely because we're dealing with a kind of conceptual or what they call epistemic improbability here. that it's very unlikely that that necessity would be the case instead of all the innumerable ones in which the rocks wouldn't have spelled anything. But it's not unlikely if my brother's here, so it favors my brother's hypothesis just by probabilistic reasoning. So you could point out the difficulty. If you go that route, you can explain any coincidence, any improbability.
And you can't explain this why it's this way.
Right, it's this why it was necessitated in this way. Now, it very well might be necessitated. You might, if you believe, um, let's say a God, that um, it was the best of all possible worlds for there to be a light permitting one, then that God would have been, if it was perfectly good God, would have done what created what is best, and that would be what is best, and then it would be necessary if that God necessarily exists did. Um, so you could have a mediated necessity, but then it would be plausible. Then it would be necessary. It wouldn't be an arbitrary one. So the question is there can be a difference between an arbitrary necessity. There's no reason you can see for it, versus one that's um, grounded in something deeper.
Yeah.
Like if you
It
were
wouldn't be a brute necessity. It would be a
yeah, it'd
necessity
be a
that.
kind of yeah, there's a kind of brute necessity. Why this versus something else versus one that's grounded in something deeper.
So that was a little aside just to cover that thing, because I know it's been raised in Fine Tuning for Life. We're back to Fine Tuning for Life, the two competing theories, that there was a designer behind it all, and therefore he made it that way for life. And the other, that there's a multiverse, it's a big lottery, and we happen to got the winning ticket. So let's go now to your fine tuning for discoverability and what that adds to this discussion.
So first of all, you can't if it's really is there is a fine tuning for discoverability, that means things are arranged in a very, very precise way, and I'll explain that in a minute, for scientific discovery, that you wouldn't expect it by chance at all. And the reason that can't be explained is that you could have in the multiverse scenario, there'd be all if there's nothing more going on, there'd be the vast majority of universes would be such that they'd give rise to observers, but they wouldn't be very good for doing science, and they wouldn't be fine-tuned. And so that means a randomly selected observer, you um, wouldn't expect to see um, to find yourself in one that's highly fine-tuned for discovery. So let me give an analogy here, and a kind of everyday analogy of why this sticks. So there'd be some universe that the observers are going to find themselves in a multiverse fine-tuned for discovery, but that we find ourselves in such a universe is what's surprising and the coincidence that can't be explained because there's no selection going on. There's no reason from our mere existence that we'd find ourselves in such a good universe. So an example is if, any improbable occurrence. So I imagine now you're going to Nevada, which has legalized gambling, and you go to the casino and you play the game and every, 50 times the house wins, and that's enormously improbable. And so you boldly go up to the manager and you tell the manager, well, this is strong evidence you rigged things because look at it, it's so improbable you would win if you did not. And the manager leans back and kind of laughs and says, well, I believe in a multiverse hypothesis. This is going to happen in some universe. There's going to be some universe in which there is, a casino. And in that casino, um, the house is going to win 50 times in a row. What's the problem? Well, the problem is I wouldn't expect it to occur here for me. That's going to be very improbable. If you allowed that kind of response that the manager gave, then any sort of probable occurrence could just be explained away, and science and our everyday inference would just be doomed. You could always just say, well, that's going to happen somewhere.
So, but isn't it just, maybe I haven't understood it, but isn't it just saying that there's another level of improbability on top of the fine tuning for life? That there's, maybe what would, if somebody said there are trillions of universe with conscious beings on them, and we just happen to be in the universe where conscious beings can discover the laws of the universe, And sure, that's very unlikely, but remember, if we've got infinite universes, then that's not a problem. So why can't someone come back and just say, well, yes, it's very unlikely, but anything unlikely is possible?
Yeah, so anything unlikely is possible. It's the reason is there's two coincidences. There's one coincidence is that let's say go back to the life one, the case. There's a coincidence that in one of those universes, um, that there is in some universe, observers. The multiverse explains that, but it doesn't explain why any in the universe we're in, we find ourselves as generic, randomly selected observers in one that allows for life. That's a second coincidence that needs to be
Yeah.
explained. And you see that all the time. I mean, if you think that coincidence doesn't need to explain, then I have universal defense for any defendant in the jury. So I just say, well, if my fingerprints are on the gun, they're found on the gun. Well, in some universe, there's going to be somebody else who commits the murder that has almost identical fingerprints to mine. So of course that's going to occur. So I'm just in one of those universes. And clearly we
And we
wouldn't
would see
allow
why
that.
that's no, and we wouldn't allow that, because there are, we wouldn't allow that in our day-to-day lives. But if someone invokes an infinite number of universes, that can always be their defense, can't it?
It could always do it, but it doesn't work because there's another improbability. So it's not improbable that that would occur somewhere, but it's improbable that I would be the one it occurs for.
And you would say that it's not so much the absolute probability of that, but it's the kind of comparative probability or comparative plausibility relative to another explanation.
Yeah, that's right. It's not that all kinds of improbable events happen all the time. So in what's called generalized Bayesian reasoning, which is used all over science, it's the comparative probability of two hypotheses. So in the fingerprint example, why it counts as evidence is that it's very improbable your fingerprints would match those on the gun. So when they do these, I learned this from crime scene investigative show, that when they match, all the parts don't match. You only get part of the fingerprints. So then they look at how unlikely it is that it would match if it wasn't your fingerprint, but it doesn't absolutely rule it out. So what you're doing is you're saying under the guilt hypothesis, it wouldn't be unlikely at all for them to match, but under the innocent hypothesis, it's very unlikely. So because of that ratio of those unlikelihoods, it counts strongly in favor of the guilt hypothesis. That just it's called Bayes' theorem, and it comes out of the probability calculus. So it's sort of a mathematical theorem that tells you when evidence counts, for which hypothesis and how strongly by looking at the differences or the ratio probabilities. It's very improbable under one, but not under the other.
And why do you think it's the case that if there were a God who created all of this, that he would make it discoverable?
So that's a lot of reasons. One, it becomes, I mean, you could say science is our most valued enterprise epistemically. So that it's been used against the existence of God, which I think is completely faulty. Some kind of modern phenomena of fashion, but right in the heart of our most prestigious enterprise of finding out the world is the sign that points to something beyond itself. That's one reason. Another reason
Hang
I
on, just to
think,
to clarify that. So are you saying that God's almost like sticking it to them?
well, not giving sign, yeah, sort of, but giving him a sign um, in kind of the most admired methodological enterprise that's been extremely successful, giving a sign that points to God. So it's like God wants to be found out, that God's existence through human capacity of reason. And it shows the ingenuity of God. And also, I think it shows another really important thing is that I think God wants us to use reason. So I think that the reason I think it's done a lot of damage, the conflict between faith and reason, because people need faith in something, but it's been put against each other. And Here it's saying, no, faith and reason actually go together. This reason actually comes from something higher, and reason's been extremely successful in science, and so we should use it elsewhere. And so I think science itself has been another issue. Science, its success has been a huge bulwark against superstition. So relativism and skepticism have been around forever. Go back to the schools of ancient Greek skepticism. So they would say, skeptical of any of our reasoning faculties, skeptical of moral faculties that we could understand what's right and wrong, good and evil. Um, and those are very tempting because it's a recognition of the limits of human reason. So it's very tempting to say any worldview is as good as any other. Any view is as good as any other. But science has served as a huge bulwark against that because science says it's been so successful. So you can't, if you're skeptical of human reason, you face the question, well, why is science work so well? There must be something to this human reason, despite its finitude. So the finitude is um, a proper recognition. Yeah, our minds are really finite, and if you take the standard evolutionary theory with regard to our mind, they were just made for survival. They weren't made for finding truth about the underlying world. So that would naturally lead to a lot of skepticism, and people recognized, if you didn't have something larger, a larger belief in some sort of a mind behind everything, God, you'd be naturally led into skepticism, which historically happened. Um, but once you believe in a God, it opens the possibility that maybe God has created the world. Um, in such a way that our minds can find it out, and that's actually that thought is what led to the scientific revolution.
Yes, absolutely. A thought that's often overlooked. But so you're saying that there's in if God exists and if God made the universe discoverable, it's not just a message of his existence, but it's almost like a encouragement to use reason for finding God as opposed to denying God. Is that what you're saying part of the
Yeah,
message is?
that's right, and so that's what was actually motivating a lot of the early scientists. They thought that, it was a huge motive for doing science is you were looking into the mind of God. You were finding out the ingenuity of God's creation. So, and how God works. So it was like a way of praising God, a way of recognizing God's greatness and ingenuity. Now, that has often been lost for a lot of people today. It still comes through that how fascinating and ingenious this creation is. But that was certainly a motivation in the early people because they had no other reason to believe um, that it was really well designed. There was this faith. It goes back to Pythagoras actually, but then gets really strengthened by the Christian tradition through the Middle Ages that that the two aligned together, Pythagoras and then through Plato, that the world was mathematically designed and that math put together with elegant mathematics.
Isn't one problem though with this idea that God's kind of sending us a message here that so few people in human history and even so few people in today's world would ever understand or be aware of this? I mean, we can put these type of things out on the internet, but it's still going to be only thousands of people, not millions of people, who will come to grips with this type of argument. So it's quite a limited kind of message God's sending at this stage, unless you feel it's just the start of something which is now going to
It's a
explode in human
start of
history.
yeah, it's a start of something, but it's also particularly important on this age of
Hmm. So
skepticism
why in this age? Oh, okay, so skepticism. Yeah.
because there's an age because what we've in this age we've learned to apply reason. It's been very successful in science, so then it gets applied back to religion. We become, if whatever religious tradition you've come from, you're now aware in a way you weren't before of all not only different religious traditions, but atheism and agnosticism, which wasn't around. I mean, you didn't dare be an atheist or agnostic in society because, that would be, you'd like get executed as because religion was thought to be central to the functioning of a state. So you found that in Athens. That's why Socrates was accused of atheism. Atheism, he didn't believe in the gods. But in any society after that, then it would be not believing in a monotheistic God or whatever religion um, there was. That's not true anymore. And so there's been a rise of skepticism. And so, and interrogation using reason. So it's like the human race in that sense has reached his is now in adolescence, right? And when they're little children, all this stuff is not going to be. So you think of the human race as a whole. When you're little children, you're not even going to be able to have evidence that stands up. And in fact, and so it's only when you reach a certain stage, and this is the stage in which we most um, need it. So I think there's something providential in the large scale of history itself um, that's going on.
Would you go as far as to say that humans discovering the discoverability is a form of revelation?
Oh, yeah, it's definitely a form of revelation. So mine is not just that it's fine tuned for scientific discovery. That was my initial one, and there was good evidence for it. But I eventually, just because part of the data and also philosophically, they end up aligning together, it's fine tuned for the discovery of discoverability. So basically, if you look at the parameters, and they're not, and I haven't gotten to that kind of evidence, but they're not only into a range that could plausibly be thought to maximize discovery, but they're in these little there's these kind of discoverability peak ranges for contributors to discoverability, and they're in that. So they're in ranges that most strongly point to discoverability, like our indicators or pointer or signalers of discoverability. So let me just give you, I haven't given you any examples yet. I'll just give you my first example, which was the easiest to understand. It has limitations, but it was easy to understand. My first example was with the fine structure constant, which is the constant that governs it's a parameters, the parameter that governs the strength of the electromagnetic force, analogous to that Newton's gravitational constant that governed the strength of the gravity. It, so this is my first one. The first quantitative evidence when I was toying around with um, I was trying to reevaluate all the physical evidence for fine tuning of life. So I started asking myself what would happen if you changed that. And what I found, one of the first things I found, is that if you increased it by a little bit, no civilization, no observers could be able to have open biomass fires. So biomass is the most natural thing you're going to get. So, and the reason is it governs the amount of radiation coming from proportion to the energy produced, the amount of radiation coming from like a wood fire. So if you're standing around a wood fire, let's say, a campfire, and you're enjoying the fire, you're seeing some of the energy of the fire going up in smoke and some of it coming out in radiation that you feel with your hands. If you were to like double the fine structure constant, there'd be 4 times as much radiation coming out now. And what that would do is very quickly it would drain energy from the fire and it would go to be, below the combustion point. So that then that constant, the value of that was essential, that it wasn't too high for us to have open wood fires, which led to the smelting of metals and the forging of metals, which, the Iron Age and the Bronze Age and Iron Age, and eventually to what the kind of science we have today, which would have been impossible without fire. And then there's a whole bunch of other effects if you decrease it. Not only would be a lot more forest fires, houses would burn down very easily. It seems, but wouldn't be able to. Your electric motors and transformers would become very rapidly inefficient, and there was other things that are necessary for technology that would go bad. So it seems like it's fine tuned, just in this small range, so we can actually even have technology.
And
And
not just technology, but you're talking about civilizations and therefore education
civilization,
and
yeah, the whole
sciences
thing.
and everything.
We'd be stuck in the Stone Age, there used to be a show that played the Flintstones. We'd be
Mm.
the
Okay, they were
people
pretty
long
clever, the
ago.
Flintstones. Okay,
Yeah.
fine.
So
Okay,
they'd
so
be
you've got
stuck.
so it's kind of it's like fine-tuning on steroids. It's like, it's taking it to the level of more than just discoverable, but uber optimally discoverable,
Right,
down to the level of how human civilization evolve or, forms
right.
evolves, yeah.
So then I found there were some things unsatisfying about that case because there's part of anthropic explanation for fire that you can so I wanted in the case of fire, it also served to help human beings evolve, the brains they have, right? Because you cook meat and things like that. So I looked for but there was also it really factored into discoverability, but I wanted clean cases where you had an anthropic range, a range that allowed for life, but then a teeny discoverability optimality range within that. Okay. So I was looking for that. Um, and I eventually did find that, and the next case was what's called cosmic microwave background radiation. It depends on the ratio, what's called the ratio of photons to matter, and I won't want to go into detail about that. But when I did the calculations, first I made a mistake and thought I'd refuted my thesis, but then I found a mistake in my calculations, and amazingly, it was this what's called a cosmic parameter, governs the overall structure of the cosmos, was set perfectly, just right, so it maximized this cosmic microwave background radiation, which that's the fundamental tool of cosmology. It looks at this radiation, this microwave background radiation permeating space, which in the 1960s was the crucial evidence for the Big Bang that turned people from a steady state, the universe existed forever, that actually had a starting point because there seemed no other way of explaining it. So it's microwave radiation that permeates in all directions from space. And what I got is a curve like this for that parameter. It just was a curve here, and we were setting at the peak. So you could just mathematically calculate where the peak was and find that we were there. And when I got that result, I sent it off to several cosmology friends of mine for verification, and they did verify it. So that was my first big result.
So just
Um,
explain that. Maybe I missed something there, but you're saying a peak for what? Discoverability or
for a peak for the intensity of the cosmic microwave background radiation. So you have this microwave radiation called the CMB, it's shortened for the
yeah, yeah.
CMB, that permeates all of space. Okay,
Yes.
it's weak. It's fairly weak. You can't cook a hot dog or hamburger or something out in space. Okay. And the stronger it is, the more you can study these very small deviations. And so the discoverability thesis would predict that it would be as strong as possible. Okay, that it could be within the parameters we have. So it depends on this other cosmic parameter called the ratio of the number of photons, particles of light, to the particles of matter, or mass of matter. And I calculated its strength via that, changing that cosmic parameter, and found out we were at the best point it possibly could be at this peak. It
Best
goes like
meaning
this.
best meaning for detectability.
Yeah, for using the
Yeah.
cosmic microwave background radiation to study the universe.
Okay, so you're basically saying that if there was a god, he set cosmic background radiation at the right level so that one day humans would discover that the universe had an origin.
Yeah, yeah, and not only had an origin, but discovered that it was actually peaked. Because you could have you if it wasn't at the maximum level, if it was like 5 times larger, 5 times less, or 5 that couldn't be 5 times larger, but was that cosmic parameter is different, it'd be weaker, but you could still find the universe had an origin, it just wouldn't be optimal. So it's not only that we found the microwave background radiation and then deduced that the universe had an origin, we also found it to be optimal. See, and I when I first did the calculation, I made a mistake and thought it wasn't optimal. So I thought my thesis was I kind of almost gave up on my thesis and that of this optimality idea and just started pursued some other things until months later I realized the mistake I made and recalculated. And I was kind of shocked when I found out, well, it was right at the peak. It was super impressive, and then I wrote to one of the cosmologist friends, and he felt back and said amazing.
And what do atheist physicists, or I say materialist, naturalistic physicists say to that observation?
Well, I mean, I've been working this out really carefully. So right now, I'm not sure what they're all going to say. I
Okay,
mean,
so it's still not
so
fully out there. Okay,
yeah, it's
yeah.
so not fully because I want to be really careful in the first. I want all the ducks together before you don't want to discredit yourself. Um,
Yeah, yeah,
you
sure,
want your
sure.
case really strong before you go out. So what I did is from there I went into particle physics. And that was because of Sean Carroll critiqued me at a conference for my ideas saying, "Well, what about particle physics?" And I hadn't really looked at particle physics. So I was worried, maybe it would just peter out in particle physics and not work because he pointed out a couple what he thought was counterexamples, which turned out not to be counterexamples once you understood the thesis. And then particle physics gave me the really strongest case where every single parameter turns out that you could adjust, turns out to be fine-tuned or even highly fine-tuned, where it would be just by chance, it'd be something like 1 part in a trillion trillion for this to be the case. And the pattern is completely consistent. And now here's where the things get there's a more fine-tuning I wanted to bring up, and that is there was a fine-tuning to make discovery optimal. But now in some places, what you have is you have when you move the parameter, you have competing factors. Like some things get better, but then maybe some things get worse. So you have it would be like if you had you adjusted something in a car, the safety might get you want to make the car really fuel efficient, but you might hurt the safety or might make a race car drive really fast, but then the safety is going to go down with whatever modifications you made. So there's trade-offs. So there's a kind of trade-off region where you could say it's plausibly optimal, and that makes these subjective judgments. Um, so I thought, well, if it was set for discoverability, you'd want something more than that didn't rely on those subjective judgments and wouldn't be in a broad range. So you'd want it to land at what I call a contributor peak. There's contributors to discoverability, just like in a car, there's contributors to quality, like fuel efficiency, safety, etc. So the idea comes something like this. There's a nice analogy for the idea. So let's suppose there was a contest in which there's like 10 dartboards and the instructions to the judge's instructions, you were supposed to impress the judges and then who was a gold medal winner of the contest, and you were supposed to hit the dart for each of the boards on the brightest spot. So the brightest spot, it's colored dartboards, there'll be various colors, and the brightest spot's going to be determined by the weight of the color and how they're visually processed. So you're aware of that, and so it makes the brightest spot, not really sharp because you're gonna have to weigh the different intensities of color. And so you come from a people group that the judges are very skeptical of that are good dart players, but you're a really excellent dart player, so you have a plan. You look at within those bright spots, there'll be places where like a single color, like red, will maximize in a very thin region. So every bright spot you hit where some color is maximal, and it's a very small region, so much harder to hit. You do it across the dartboards. And then if the judges recognize that, you want to make sure it's recognizable. They're going to say, well, wait a minute, this person is really good. How did they hit those really small um, regions? And that's going to be a lot more impressive than just hitting the bright spot. And so it's going to overcome their skepticism. So that's what happens in the case of fine tuning for discovery. It goes, there is contributors to discovery, and it maximizes those particular contributors. And those are, you could calculate those and calculate small regions that make those peaks. So the fine tuning becomes a lot more impressive, which is what you would predict by the discoverability of discoverability thesis. If it was made so you would discover the discoverability. So you can make criteria for where the dart should land, or in this case, the parameters should be definitive criteria, and so it becomes a highly predictive thesis. And then the predictions turn out to be correct across the parameters.
And then, of course, what you'd need to do is have somebody else do all of these analyses independently, and hopefully come up with the same estimations as you.
Well,
Have there
here's the
been
yeah,
other people?
no, here's the neat thing about it, and this was the last stage I'm working on the project, is I know there's gonna be a huge barrier in the scientific community for taking this kind of thing seriously. It sounds like intelligent design,
Oh, you're going
etcetera.
to ask AI to do it.
No, I'm not gonna ask AI to do it. What's great about, well, it does help in some of the areas, because I could just say, "Here's the, prompts to give," and AI will verify it. So, in some of the cases, that's true. Um, but the other thing is a lot of these, um, are, the huge criteria for the a good peak that you want is high recognizability, like almost immediate recognizability. So once it's pointed out, you just point out something in the literature, physicists will immediately see it. No
Okay.
big calculation required. So a lot of these are already noted by physicists in the literature. They'll say something, wow, this is really coincidental. And wow, this is really good for discoverability. Aren't we lucky? You already get a lot of that, and look, just no one has put it all together. So in the case of neutrinos, various of the parameters, they're already stated, like I have an introductory book to particle physics, and then it just states, well, it just happens by chance to be in this really good spot for discovering this, major piece of the neutrino puzzle. And you'll see this across different parameters. Aren't we lucky? Like in the case of the Higgs boson, it says the a couple people say the Higgs boson mass was, um, the mass was born under the Higgs boson was born under a very lucky star. Its mass value is just right for this. But see, no one puts it all together across the different things. They just independently note. So there's a lot of cases like that. And then there's other cases that maybe or point to a coincidence like the dark energy, where it says there's called the cosmic coincidence problem. Why is the dark energy just have this relation to the matter density that is so close to 1? So it's got a name, cosmic coincidence problem. Well, the discoverability thesis predicts that. So it's already noted in the literature. Now, other cases are, if they're not noted, they're almost obvious once they're pointed out. So a lot of that's a criteria. Those are the peaks you really want, because they're going to be able to, they not only led me into it, because I wouldn't have noticed it otherwise, because I wasn't looking for it, and they're going to help get it. So them really highlighting that stuff.
Let's say you put this out there and people are impressed and convinced by it. It's still, someone could argue, it only takes you to the idea of a kind of cosmic mind or a kind of cosmic rationality. Maybe, why does it take you to theism as opposed to, say, a monism, or kind of, everything is part of a wider consciousness? Are you claiming it takes you to theism, or is that now going into more faith?
Well, I'm claiming it takes you it gives you one essential element it gives you is a providential, um, that there's a providential God. But there's another reason for theism, and that has to do with, and I have this, an article coming out, and um, it's already came out, I think, on this. So one reason is it shows a kind of providence. You don't get deism out of this because things are set up for us. Okay. Deism just says, well, you just get life and that's it. So that already narrows down the range. But what about some kind of finite God or some other God? Where in that piece I show theism is the only really one that can answer the leading atheist objection to belief in God. And that's, articulated by Richard Dawkins, a whole bunch of other people, going way back to David Hume. It's the most common objection, is the who designed God objection, is that if there is a God, then God would have that mind, God's a mind, that the idea is the designer of an artifact must be have as much, um, organized
Need for
complexity.
explanation. Yeah,
Yeah,
need for
as
explanation.
but what you could in the case of theism, that's not true, and there's several routes you can get there and show that that's not true. That's true for an anthropomorphic God, but not true for theism because if you had the one simple way of putting it, if you had a bounded mind that had boundaries on it, then there'd have to be some laws that determine what those boundaries were, and so you'd be getting back to a kind of fine tuning for those laws. But if you start from the assumption either consciousness is fundamental or consciousness is not fundamental. That's one route to it. I have another route too, but I'll just do this route. If consciousness is fundamental or consciousness is not fundamental, okay, 50% probability, um, that's uh, either one. Then if the consciousness is fundamental, you get um, will goes with consciousness. So then the simplest or the way to go from there that we don't have to have any fine tuning is the will and consciousness are themselves unbounded. So unbounded consciousness goes to omniscience, unbounded will to omnipotence. And then you get perfect goodness. And this is where kind of argument given by Richard Swinburne is that um, goodness is self-motivating. That's what goes a thesis going way back to Plato and other traditions that if a being recognizes the good, they will be motivated to do it. It's what's desirable in and of itself. And so the reason we don't do the good is because we're either ignorant or we have some conflict counter desire. We're not perfectly free. We're constrained by other desires. Well, God is omniscient, can't be ignorant, and not constrained by other desires. So then it follows that God is always going to do what is good. God is perfectly good. And so then once you get that, and then with the assumption that it's you say we can glimpse some goodness about there being beings like us, then you get an explanation of fine tuning. And nowhere there do you invoke any kind of coincidence because an unbounded mind, a coincidence requires some sort of parts or metaphorical parts that have to be arranged in the right way. Like, if you find a picture of one of our famous presidents, Abraham Lincoln, you find that in your roommates, I do talk to college students, your roommates, back of the refrigerator in a mold, in the mold that's growing there, and you pull it out and you say, "Wow, this she's being slobby again." And then you find Abraham Lincoln picture, you're not going to just attribute that to chance. But what makes that non-attributable to chance is there's parts. What makes that improbable is you could imagine all the different arrangements of parts that it wouldn't mean anything. But there is no parts to arranging God, and that's been held throughout the theistic traditions. And that's what another paper, what I think I showed is all the other alternatives to theism end up running into the who designed God objection. So the upshot is what I've used is leading atheist objection to God to show no, it doesn't eliminate a certain kind of an infinite God, unbounded God. It eliminates all the other ones.
Yeah, I mean, that's one of the common kind of sticking points in all these discussions is that atheists are denying the existence of a God that theists don't even believe in anyway. So,
Right, right. But then Dawkins says, well, you can't understand. Like you look at Aquinas as God, how can you understand it? Well, see, I don't start from being as fundamental. I start from the consciousness, and I think you can understand that. That
or you could just say you can't understand it, but we can say it has certain properties, and I think that's something
yeah, as
which
long as you can do that, you can't.
materialists find hard to accept, but it works for many theists.
Well, you have to be able to enough to assert that it has the properties that would give you a fine-tuned universe, because otherwise you could just say anybody could say that, right? So you have to understand it enough for that.
Okay, we're coming towards the end, but let's just zoom out a little bit here. So you've made an argument here for theism based on fine tuning for discoverability and discoverability of discoverability, and it's pretty watertight from your side of things. Why do you think it is in these theist atheist debates that have been going on for hundreds of years that none of these arguments really seem to change anyone's position? They certainly strengthen the kind of they serve as justification for the positions that people already hold. but they very rarely convince someone on the other side. Why do you think that is?
Yeah, so there's one question why you think mine's different, where it's quantitative and it's not subject to a multiverse objection. So I do think it's a lot more powerful than the other one.
Do you think it'll have more success?
I'm hoping so because I do think it is a lot more powerful. It's we admire science and it's got the objective component to it. So you're forced in. When the people took the fine tuning very seriously. So the fine tuning did the old fine tuning with fine tuning for life, but there was that escape hatch, which was multiverse. So a lot of people went with the multiverse escape hatch. So it did have uh, significant impact. And now, why in the past? Because I think God has been um, gets caught up part of it is not just, human there's part of it is what Thomas Nagel says, "I don't want there to be a God," because it impinges on your, sense of autonomy. So and that's partly because and so Thomas a famous philosopher, Thomas Nagel says, even though he has intelligent friends, a lot of them that believe in God, it greatly disturbs him. He says, "It's not because you know, it's not because I've just been an atheist." He says, "Deep down, I don't want there to be a God," and he thinks that motivates a lot of atheism and the reductionistic views because it gives you a sense of control, a cognitive control. So God, just at the level of the God invokes mystery, and people want to have it all figured out in their minds because you have to give up a kind of control that you understand reality. There's a kind of I call cognitive control you have to give that. And you find that actually throughout I mean, I've found a lot of quotations from that from philosophers and others, like one of them about why he's himself a materialist philosopher, John Searle, um, but he criticizes the other materialist philosophers, and he says that these views just don't work. But why do they hold them? And he says it's a terror. He uses the word terror of the only alternative, an immaterial soul. And then that leads you, he says, to a kind of supernaturalism and all the things associated with that, which they're terrified of. So he uses the very word terror for that, which is very telling. Um, and then you have like C.S. Lewis at his own Confessions, the famous Christian Oxford Don, who was a Christian apologist, for those who might not know, and also just a Christian philosopher who had, when he was a materialist, he said he didn't want there to be a God. One of the reasons didn't want something to go bump in the night. So there's that whole aspect of things. There's another whole aspect of things is that there's a bad association for a lot of people with God. Um, God has been used, yeah, not to take political sides, but the religious in our country, the religious right, they're huge support for Trump. So now that gives um, an association between Trump and his immoral morality with God and hypocrisy and all those things. They're going to say, I don't want to have anything to do with God. So there's been a whole bad association with religion. So they associate God with religion, which they find very oppressive or hypocritical or immoral. And so you have that's another huge factor. You have Alistair McGrath. He's a very well known in England. You're coming from England, right?
That's right.
Okay. So he's a well known Christian theologian, kind of a leading one in England. And he held the Oxford chair on science. I think it was Oxford chair on science and religion recently. So he has a book on the twilight of atheism. And he says a huge part of the rejection of belief in God is that people felt that the morality of Christians um, was lower than the morality of non-Christian society, and it was a moral critique. So, for example, the belief he cites the belief in a particular area of a belief in eternal conscious punishment for those who didn't believe, let's say, in the Christian faith or didn't believe in God, which seems like makes God into a moral monster in their view. And then he says that was the real leading reason why Darwin rejected God. He couldn't imagine that his own father was burning in hell forever because his father was an unbeliever. That just didn't make he couldn't imagine how there could be a loving God, huge disjunct. So that's a lot of what's going on. And there's a whole modern story of modern philosophy of um, it really goes back to, I think, Occam, that God is portrayed as pure, unlimited will instead of the goodness is no longer stress, and then God's will is in competition with our will. But now, in the case of discoverability, that's no longer the case. God wants to work through human beings, and is valuing what we do in our enterprises. So I think a lot of it is there's a kind of legitimate or this bad association that's playing a role.
So you're going to release this in a single academic paper tying all of this together, or
I
in
am not
several installments?
I don't yeah, I don't kn I'm not gonna sure how I'm gonna release it. We're kind of in a new era of how to release things. There's YouTubes, just like we're doing the interview. I in this way, I've integrated my own belief in God in my own life into sense of providence, so I'm kinda leaving it up to that and just doing my part right now and getting it in a really clear, compelling way. And I know that's a step that's really important for new things. I understand the history of science. New ideas, even those that turn out later to be right and revolutionary, get huge internal resistance initially. And this is even going to have more resistance because of it's doing this metaphysical and belief in God. It's going to get misunderstood. Anything that Murphy's law of misunderstanding, if it can be misunderstood, it will. And so you really want the big areas you wanna express it in a clear and intuitive way that it's, protect as much as you can. Now you can't completely eliminate it, but that's what I'm planning on.
Well, I hope this hour on our channel has gone a little way to as part of that overall project. Robin Collins, thank you very much for joining us today.
Thank you.